Welcome back to Geometry, Chapter 12. I said it right that time, Section 5 in this book. We are almost at the end. We have this tape and 2 more, and you will be done with geometry. Yay! Alright, so we're talking about volumes of pyramids and cones. This is what I like to think of as classical geometry. We're talking shapes, volumes, areas, the classics. So, if you're working along with all the homework with this, one of your homework is going to be to make, out of like an old cereal box or like an old Crunch and Munch box or something, you're going to make a cardboard cube with the top out. And then you're going to make a cardboard pyramid with like the bottom out. So it's like a scoop, a pyramid scoop and a cube scoop. And then you're going to use the pyramid scoop to scoop up popcorn or dried beans or something and see how many scoops it takes with the pyramid to fill up the cube. They'll have the same base and the same height. What's the relationship? And if we were in class, I'd say, what do you think it's going to be? And people would guess maybe 1 scoop, or people would say, no, maybe 2 scoops. Turns out it's 3 scoops. 3 scoops of a pyramid to fill the cube. So if I could turn that over and scoop popcorn with it, that's what it would be. And we can see that in our formula. The volume of a pyramid is 1/3 base times height. So it's the area of the base times the height of the pyramid. And it's also the same exact formula for a cone, and that looks terrible. These are better cones. Pretend like I drew it that good there. So it's the same exact formula, 1/3 the base, the area of the base times the height. With a cone, that base is a circle, so the area is pi r squared, 1/3 pi r squared height. Easy. All of these, you write your formula. You figure out your knowns and your unknowns. You sing substitute in, solve for what you don't know. And that's why it's so good to take geometry after Algebra 1. You get this year of practicing formulas, solving for x, solving for your unknowns, before you get tossed into the deep water of Algebra 2, where the real fun begins. Alright, so here I have a hexagonal pyramid, meaning the base is a hexagon, a stop sign. Each is regular, and each little side, each of the 6 flat things, is a measure of 3. The height is 4, and we want to know the volume. Well, the volume is 1/3 base times height. How do I get the area of this stop sign when all I know is that each side is 3? Well, this is what you know, that because it's regular, it is divided into 6 regular, exactly the same little triangles. And here's a blow up of one of those triangles. It's 3 on that side, 3 on this side. To get its area, we need base times height, and we don't know its height. Now, its height is this line from the center to the side. And remember, it gets that name, fun name, apothem. So that's what we need, and we can solve it using the Pythagorean Theorem. A squared plus b squared is c squared. A squared plus b squared is c squared. The c has to be the hypotenuse. So 3 is the hypotenuse. A can be the 1.5 squared, and b is what we're solving for. 1.5 squared is 225. Now, why is b not alone? It's got a 225 in squared. We get rid of the 225 first by subtracting it from both sides. 9 minus 225 is 6.75. Then why is b not alone? It's squared. What's the opposite square root? What you do one side, you do the other. And we get the height, which is this apothem, is 2.6. And now we can get the area of this triangle. It's 1/2 base times height, 1/2 3 times 2.6. And that's 3.9, but we don't have 1 triangle, we have 6, so we multiply by 6, and we get this, the area of my stop sign base. Now, that wasn't what they asked for. They asked for volume. But I've got base and height, and now I can do it. 1/3 base times height, that's the volume. Ta-da! See? You can do this, can't you? Okay, here's it with a cone. What's the volume? 1/3 base times height. This is the height, 17.7. This is the radius, 12.4. The base is equal to pi r squared. Pi radius squared, 12.4 squared. There's my 1/3, and the height 17.7. put it all in your calculator exactly like that, and you get approximately 1250. The more correct answer is this one with pi, where you do everything but leave the pi alone and leave it as pi, but nobody knows what that is, so this is the one we understand better. But on the SAT, a lot of times that's the answer they want. So make sure you can get both. Here's another one. Notice this cone is not just my bad drawing, it's shoved over. So it's okay if it's not straight, the formula still works. The height is 4, the radius is 1.5, the formula for volume is 1/3 base times height, 1/3 pi, r squared times height, which is 3 pi, or 9.42. Here's another one. This time they gave us the volume and the height, and we don't have the radius. We just sing substitute and put it in the formula. Underneath volume, write the volume. I left off the 1/3 there. Whoop. Did I leave it off anywhere else? Nope, looks good. Alright, under 1/3, write 1/3. Under the base, put pi r squared, but r is an x this time. Underneath height, put 13. And now we're going to solve for x by doing the opposite. So what's making this ugly is this 1/3. So step 1 for me is to multiply both sides by 3 so that gets rid of that fraction. Those cancel out, and I get 3 times 2614 equals 13 pi x squared. Why is x not alone? It's squared and it's got 13 pi. I'm going to do the opposite and divide both sides by 13 pi. And then I get this divided by 13 pi is x squared. I'm going to put it all in my calculator and take its square root. Be sure to use that alpha y equals to make it as a fraction, or put it in parentheses, the numerator and the denominator. Also here, wherever you put in this third, put it in parentheses, or use the numerator denominator button, or else your calculator has a hard time knowing what you want divided. Okay, so that one's 13.86. The next two are word problems that you can see, like with this, they got the volume of this flat part and then the pyramid, and it's what they used to use on ships. They would have this glass thing that they would make flush with the ship deck, and it would take the sunlight and it would direct it down. It was a light catcher that would direct it down to the lower levels of the ship. And it worked great. And so I saw this thing on TV where a guy was saying, you know, there are all these places in the world where kids, like if it's raining or something, they can't do their homework because it's dark in their house because they don't have electricity. And he said it works. He thought about this old idea and he started making them, cutting the spout part off of 2-liter bottles and putting that in the roof so they could seal it real good, put the lid on real good so it doesn't leak, and it works. And it was making it where all these kids could do their homework in the house during the day. Doesn't help them at night, but it was actually improving education among some very poor people, so that was cool. And then the next problem is about measuring the rate of oil going through a funnel. It is stupid. No one does this. If you're putting oil in the car, I don't know if you've done it before, but I have. You put the funnel, you pour it. If you're pouring too fast and it starts to look like it's going to go over, you back it off a little. We don't need a math problem to tell us not to overflow the oil over the funnel and get it on the engine, because it burns and it smokes and it stinks and you don't know if there's something wrong with your car or if it's just the oil burning off. All right. So we are just boycotting silly problems, but that one's cool. Be sure to look at it. Look at all the examples in your books, make sure you understand them, and come back. We got 2 left. Math is great.